Assalamu alaikum. My name is Mahwash Zehra Kirmani and I am a lecturer in chemistry at Shaheed Millat Government Degree College for Women. This is an online tutorial for the student of class first year. My topic is balancing oxidation reduction equation using ion-electron method. As in our college, the academic syllabus has been completed, and because of this pandemic situation, the students have to prepare themselves for the final exam at home. This online tutorial helps the student to revise their syllabus. I selected this topic as it is a compulsory part of examination paper for both theory and practical. So now we start our lecture. Rules for balancing redox equation by ion-electron method. There are certain rules for balancing the redox equations. Here we have to discuss the oxidation of H2S, that is hydrogen sulfide, with nitric acid in acidic medium. Step number 1. In first step, we have to write the skeleton equation. Here we write this skeleton equation. Now in step number 2, we have to transform the molecular equation into ionic form. This is the ionic form of above molecular equation. Here the oxidizing agent is nitrate ion because nitrogen undergoes a decrease in oxidation state. Here the oxidation state of nitrate ion is +5 in this nitrate ion. We have 3 oxygen atom and the oxidation state of oxygen atom is -2. So -2 multiplied by 3 is equal to -6. One negative ion is overall charge on this radical. So 6 minus 1 is 5. So therefore the oxidation state of this nitrogen atom is +5. Reducing agent is hydrogen sulfide. Here sulfur undergoes increase in oxidation state. In hydrogen sulfide, hydrogen has +1 oxidation state. Since we have 2 hydrogen atom, so the oxidation state of hydrogen is +2 and therefore sulfur has -2 oxidation state. Step number 3. We have to split the ionic equation into 2 partial equations. The first one is reduction reaction and the second one is oxidation reaction. In reduction reaction, nitrogen goes from +5 oxidation state to +2 oxidation state, and the oxidation reaction, sulfur goes from -2 oxidation state to 0. As in free state, the oxidation state of an atom is 0. Step number 4. In this step, we have to balance the partial equations. Since the medium is acidic, oxygen atom is balanced by adding water molecules. In the first partial equation, there are 3 oxygen atoms on the left and 1 oxygen atom on the right. 3 minus 1 is 2, so we have to add 2 water molecules on the right. To balance hydrogen atom, we have to add H positive ions. There are 4 hydrogen atoms on the right. Therefore, we have to balance the hydrogen atom. We have to add 4 H positive ions on the left hand side. In the second partial equation, 2 H positive ions are added to balance 2 hydrogen atoms on the right. Step number 5. Balancing the charge by adding electrons. In the first equation, 3 electrons are added on the left side. On the left hand side, nitrate has one negative ion and hydrogen ions. There are 4 hydrogen ions. So 4 minus 1 is 3. There are 3 positive ions on the left hand side. So to balance these positive charges, we have to add similar number of negative charges on left hand side. In the second equation, 2 electrons are added on the right hand side. Since there are 2 H positive charges on the right hand side, so we have to balance this H positive charges. We have to add 2 negative ions on the right. Step number 6. In order to equate the electron lost and gained, first partial equation is multiplied by 2 and the second partial equation is multiplied by 3. That is, we cross multiply the number of the coefficient of electron in both the equations. This is the first partial equation. We multiplied this partial equation by 2. Whole of the equation is multiplied by 2. And this is the second partial equation. We multiply the whole partial equation by 3. As you see on the screen that there are 6 electrons common on both the equations. In step number 7, we have to cancel out the same number of electrons and add partial equations. So the new equation is this. In this equation, 8 H positive ions are on the left hand side and 6 H positive ions on the right hand side. Since 6 H positive ions are common on both sides, hence they are cancelled out. So the new equation is this, and this is the balanced chemical equation. This is the ionic form of redox equation. To convert this ionic form into molecular form, the equation may be converted back to molecular form by combining nitrate ion and hydrogen ions. So this is the new balanced equation, and this is the properly balanced equation. Assignment: the oxidation of ferrous sulfate by potassium permanganate in acidic medium. Thank you.